This is Anita Wood, and welcome to this topic snippet introducing some central concepts to any programming language, variables and their data types. I'm going to use a piece of pseudocode throughout this video, so I need to provide you with a simple explanation of the problem that's being solved. We're going to calculate how much pay an employee will receive for the pay period. The user will input the name of the employee, the number of hours the employee worked this pay period, and the rate that the employee is paid. Now, the pay is the number of hours the employee worked times the rate. So when you're all said and done, you need to display the employee's name with their pay. The most fundamental way that a program stores an item of data in memory is with a variable. A variable is a named storage location in the memory. The data stored in a variable may change while the program runs, hence the word variable. Notice in the pseudocode shown here, the programmer defined names are name, hours worked, rate, and pay. All of these are the names of variables. The name variable is used to store the name of the employee. The hours worked variable is used to store the number of hours this employee worked. The rate and pay store the rate of the employee is paid for their time, and pay will receive the calculated pay the employee will receive. These variables are symbolic. They're symbolic in that they're made up by the programmer, and they represent locations in the computer's RAM. Remember RAM? It's the random access memory in the computer. When the data is stored in a variable, it is actually stored in RAM. So let's illustrate the way the variable hours worked name represents a memory location. Here's the representation in memory. The variable hours worked is holding the value 43. The number 43 is actually stored in RAM at address 8, but the name hours work symbolically represents the storage location. One way to think about variables are that they point to the location in memory where the value actually resides. Programming languages don't force us to deal directly with the memory and its addresses. All we're going to have to fret about is the variable and its current value. So for us, we have the variable which currently contains the value 43. If it helps, you can think of a variable as a box that holds data. In the figure, the number 43 is stored in the box named hours worked. Now, only one item may be stored in the box at any given time. If the program stores another value in the box, it will take the place of the number 43, and 43 is lost. You just saw variables allow you to store and work with data in the computer's memory. Part of the job of programming is to determine how many variables a program will need and what types of data they will hold. So let's look closer at the pseudocode a minute. The lines beneath the word declarations are just that. These are called variable declarations. Variables must be declared before they can be used. A variable declaration tells the compiler the variable's name and the type of data it will hold. The first line indicates that the variable's name is name. Also, there's hours worked, rate, and pay. The word string stands for string, so the variable name will only be used to hold a string. Num stands for a number. The variables which have this prefix indicate that the variable's hour work, rate, and pay will only be used to hold numbers. Each programming language has its own set of rules for creating variables. Throughout the textbook, you're going to find the author respects these rules that I've listed here. However, if you're also working in a particular language, there may be more rules and restrictions on variable naming. The first rule we will respect is variable names can only contain letters and numbers, no special characters, and they cannot start with a number. So 3D graph is not a valid variable name because it starts with a number. Mixture number 3 is not a valid variable name because it contains the special character #. Now, variables can only be one word, but that doesn't mean we're limited to having it only contain one word. You can and should combine words when creating variables so that they're more descriptive. For instance, we have the variable hours worked. Notice to make the variable more readable, we capitalize the second word worked. This type of formatting is called camel casing. So hopefully you can see the bump. You can also adopt the format called Pascal casing, where you capitalize the first letter of both words represented in your variable. Now, when you're choosing names for your variables, make them have meaning. By that, I mean choose names for your variable that give indication of what they're going to be used for. Now, you might be tempted to declare variables with names like HW or X. The rather nondescript name X gives no clue as to what the variable's purpose is. As you see here, the variable name sum is more representative of what will be, how and what it will be used for in the program. Finally, whatever standard or rules you adopt, consistency matters. Stick with it. For example, if you started using camel casing, use camel casing throughout your program. Now, computer programs collect pieces of data from the real world and manipulate them in various ways. And there are many different types of data. In the realm of numeric data, for example, there are many types of numbers. Numbers can contain various numbers, integers and decimals, positive and negative. Then there's textual information. For instance, names and addresses are stored as strings of characters. And when you write a program, you must determine what types of data it is likely to encounter. So for each variable, it has a data type, which defines the type of data the variable can hold. Selecting the proper data type is important because the variable's data type determines the amount of memory the variable uses, what operations it can be used with, and the way the variable can be formatted and store data. There's one more type of data that will be introduced when we discuss decisions. They're going to be called Boolean. Now, they're very limited in what value they can hold, only true and false. So it's important to select the data type that's appropriate for the type of data with which your program will work. The next area in our pseudocode begins the logic that will accomplish solving the problem. Remember, we're calculating the employee's pay. The arrow points to what we will call an assignment statement in the pseudocode. The statement is calculate pay by hours worked times rate. Shown here is a typical representation for assignments using pseudocode that's closer to programming language. I'm talking about this statement right here. Notice the equal sign operator. The equal sign is called the assignment operator. It is just one of the many operators we will learn about. In general, operators perform operations on data. How this statement is read is to store the value that is calculated to the left of the equal sign in the variable to the right of the equal sign. Specifically, we multiply hours of work by rate, and the result is stored in the variable pay. The statement here we see below, 42 equals pay, is not the correct format for an assignment. There must be a variable name at the left of the assignment operator. The statement to the left is not what we normally use in pseudocode. Pseudocode, remember, is English-like statements. And so we see at the right is the pseudocode representation for an assignment statement. Before we can use a variable in our program, there must be something stored in the memory location for that variable. Here I expanded our memory to show hours worked with a value of 43 in memory, and there is another variable called rate, and it points to memory location 4. Notice that memory location 4 is currently empty. If your program has this memory established as shown here, and the assignment statement here is to be calculated, you're going to get an error. The error is because currently there's no value inside the memory location for rate. In computerese, we call this undefined. Now, there are several ways to remedy the undefined state of a variable, so we don't find ourselves experiencing this error. Some languages, what they'll do is assign a default value to variables when they're declared. But we're not going to assume this is available while we design our logic. So we have to find other ways to remedy this undefined situation. You can ask the user to provide a value through a read statement. You can make a assignment statement that is an assignment of a literal value of 10 to the variable. Now remember, literals are talked about more in the book. Quickly, they're just what you type when you type an actual number or text string. The actual number or the string is the literal. Finally, you can initialize a variable at the same time you declare it. Here you see the declaration portion, num is rate, and is followed by the initialization portion, rate equals 10, okay? That concludes this topic snippet video on variables and data types.